Okay, if you're a machinist, you know exactly what I'm talking about. You see a job come in, and it involves tapping threads into something like Inconel or Monel, and you just take a deep breath. Because you know this isn't going to be a walk in the park. It feels less like a science and, let's be honest, more like a gamble.
And when that gamble doesn't pay off, well, this quote from our source material absolutely nails it. You hear that awful sudden crack, and the tool just snaps like dry spaghetti. Another expensive tap gone.
It's a sound that probably makes you cringe, right? It's all too familiar for anyone who's had to wrangle these incredible and incredibly difficult materials. I mean, they're built for the toughest jobs on Earth, which is exactly why they fight back so hard.
So that's the big question here, isn't it? Why are these alloys so stubborn? And more importantly, how do you actually win the fight? Well, that's what we're going to break down. We're going to look at the why and then lay out a game plan to turn this gamble into a predictable science.
First things first, to beat your opponent, you have to understand him. So let's dive into the science of what makes these materials such a machinist's nightmare. See, it's not just one single thing that makes Inconel so tough. It's actually a triple threat. 3 nasty properties that all team up against your cutting tool.
Okay, first up, you've got work hardening. The literal instant your tap makes contact, the surface of the metal gets way harder. Then there's heat. These alloys are basically insulators. They're terrible at getting rid of heat, so it all gets trapped right at the tip of your tool. And to top it all off, they're sticky. The material literally smears and tries to weld itself to your tap. And here's the real kicker. These 3 problems don't just add up, they multiply. They feed off each other and create this escalating, vicious cycle that almost always ends one way, a broken tool. Let's walk through this train wreck in slow motion. Your tap touches the metal, which instantly work hardens. Now you're trying to cut this harder surface, which creates even more heat. That heat gets trapped, which makes the material even stickier. That stickiness causes the chips to smear all over the tool, cranking up the friction, which sends the torque skyrocketing until snap. Game over. Okay, so we know the enemy. Now how do we fight back? This isn't about just pushing harder. It's about being smarter. It's about strategy. The way you break that vicious cycle is by taking back control. It's about managing the key variables of the cut so that you are dictating the terms, not the material. And believe it or not, the single most powerful variable you can control is also one of the most basic: the size of the hole you drill before you even start tapping. We're talking about the minor diameter. I mean, think about it. In a soft material, a slightly undersized hole is no big deal, but in Inconel, it's a total disaster. An undersized hole forces your tap to do 2 jobs: cut a thread and plow through a wall of work-hardened material. Just by opening up that minor diameter, even just a little bit, look at how the torque just plummets. You let the tap do the one thing it's designed to do: cut. All right, so you've prepped the battlefield by dialing in your hole size. The next move is choosing the right weapon for the job, and that means looking closely at the tap itself. Look, these nickel alloys will chew up and spit out a weak cutting edge. You need a tap designed with a strong geometry. A little bit of honing on the edge gives it the strength to stand up to that work-hardened surface without chipping. It's a balancing act, you know? You need enough relief so the tool doesn't rub, but not so much rake that you create a fragile, weak cutting edge. But the fight's not over, especially when you're tapping a deep hole or, even worse, a blind hole. In these cases, chips are your absolute nemesis. They're long, they're tough, they're stringy, and they have nowhere to go. So they pack up, they get wedged, and they cause a sudden, massive torque spike that'll snap a tool in a heartbeat. And this is where the spiral flute tap becomes your hero. It's designed to act like a screw, actively pulling those nasty, stringy chips up and out of the hole, away from the action. This keeps the cut clean and, most importantly, keeps the torque stable. All right, we've got our hole size dialed in, we've picked a tap with the right geometry. Now let's cover a couple of final, really critical tactics to seal the deal. First up, you've got a big choice to make: cutting versus forming. Now, form taps are tempting, right? No chips, and they can work in something a little softer like Monel. But our sources are pretty clear. For tough stuff like Inconel, the forces you need to form threads are just astronomical. So a cutting tap is almost always the safer, more predictable choice because it keeps that torque under control. And that brings us right back to our old enemy, heat. Remember how these alloys trap heat right where the work is being done? That heat is what dulls your cutting edge, cooks your coatings, and makes that sticky friction even worse.
So your number one priority, get that heat away from the tool and fast. This is where a good, high-quality lubricant or high-pressure coolant is non-negotiable. Its main job is to pull that destructive heat away from the cutting edge before it has a chance to ruin your tool and your part.
So when you put all these pieces together, you start to see a clear path forward. Tapping these brutal alloys stops being this random roll of the dice, and it becomes a process you can actually control.
So, let's recap. Here's your checklist for success. 1. Control that minor diameter. It's the biggest lever you can pull. 2. Choose a tap with strong, smart geometry for the job. 3. Have a solid plan to get those chips out of the way. And 4. Drown that cut in coolant or lubricant to manage the heat.
When you consciously manage those 4 things, the whole game changes. You're not just crossing your fingers and hoping for the best anymore. You're taking charge. You're turning a gamble into a predictable, repeatable, successful process.
Look, the material is always going to be tough. That's why we use it. But with the right knowledge, with the right strategy, the process is absolutely manageable. So the only question left is, what are you going to go machine next?